Hello everyone. Today we are going to start the lessons about the wireless network technology essentials. It means in today world, in modern world, there are a lot of wireless techniques on your mobile phones, on your vehicle, on your transportation systems. So, what are the hidden facts of these old technologies? Today we are going to discuss about some behind facts or essentials or basic things, the technology that cover up with the wireless networking. So let's move with our lessons. In the first section, we are going to discuss about standard bodies. There are so many new technologies are emerging in recent world and modern world. So, how we can control those technologies and the effects of these technologies. So, there are so many standard bodies in the world who are controlling those technologies and these conditions to make this world so comfortable for the humans. So let's discuss about standard bodies which are supposed to facilitate the wireless technologies. So in next slide, in next screen, we are going to discuss about the standard bodies which are commonly known as standardization bodies. So let's discuss our topic. Now, there are different standards bodies exist in the world for different industries and different purposes. Those bodies are create the rules and regulations for several sectors. In telecommunication field, several standard bodies are involved to create the communication protocols, models, and standards. They provide the framework for set up, maintain, and regulate the network applications for different goals. Some of the standard bodies are commonly that IEEE, ISO, ANSI, KATS, GISC. So these standard bodies are involved in with wireless technologies and with modern computing technologies. So in next slides, next screens, we are going to discuss about the some most famous standard bodies. So next move it. So, after discovering some important informations about different standard bodies in world, which are most popular like IIE, ISO, and ANSI, now we are going to discuss about some telecommunication standards which are formed by those companies or those standard bodies. So, let's move with the next screens. Among hundred of telecommunication standards, we are going to first talk about the IEEE 802.3, commonly called as Ethernet. So, uh, as we know that IEE stands for otherwise. IEEE stands for Institute of Electrical and Electronic Engineers. So this is institute introduced several standards for local area networks, which known as IEEE 802 standards. So these standards will come up with different versions or different types. For example, IEEE 8.802.3 is standards that describe local area network standards such as CSMA, CD, commonly known as Ethernet. So, when discussing about little history about this Ethernet technology, um, uh, Palo Alto Research Center, or commonly known as Park, found this standard in 1975. It originally designed as a 2.94 Mbps system to connect 100 computer within 1 kilometer area uh, using cables called this is actually called as Ethernet. So later, uh, several Intel and DEC drove up standard support to 10 Mbps Ethernet. It means they improve the bandwidth actually with multiply technologies. Standard is one of most used one for most common type of networks such as local area and wide area networks. So uh, in current world, in present world, there are different versions of IEEE 802.3 protocol. So in next slide, next screen, we are going to discuss about those versions. Okay, let's start our discussion about wireless local area network. Otherwise, most of we know that the word called Wi-Fi. So, uh, IEEE introduced this 802.11 standard in around 1997. So this standard is exists in different versions. So this is basically known as uh, extended version of local area network, otherwise wireless local area network technology. So this define wireless interface uh, in the network. So uh, network users can connect to the network without using wires, and here normally we call that transmission media of data is unguided. So uh, people can connect to the network without considering the place or direction where their workstations are in. So this is a very common technology or very common wireless technology of connecting the machines in your office areas or uh, within limited geographical areas. So also there are different variations in these IEEE 802.11 standards. So let's move with those standard or those versions of this standard, I mean wireless standard versions. Okay, let's discuss about ISO OSI model. This is a very common standard in telecommunication. So most of the network use either this type of model or otherwise the most recent type of communication model called TCP/IP. Anyway, the TCP/IP model also one of deviation from ISO OSI model. So to understand the TCP/IP model also, it is very basic. It is very compulsory to get some idea about OSI model. So let's discuss about what is OSI model and how these OSI model is helping to the developing or implementing network. As we know, OSI is a standard formed by International Standard Organization. Uh, this is a focus to create, implement uh, the communication network. So OSI contains set of protocols and concepts that are grouped together uh, for the purpose of simplifying and facilitate communication between computers or network devices. Through this, we can build up communication network without changing the model, or otherwise we call architecture of the different hardware or software systems. So then now we have to move with what are the layers of the source and model and how they are interact each other to complete the communication task. Okay, OSI model layers contain 7 layers. The application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Let's look at another most popular networking model called TCP/IP. This is little bit compressed version of OSI model. Uh, Once we have examined about the OSI model, we can simply understand what is this TCP/IP model is. Basically, TCP/IP model have only layers. So the TCP/IP model is concise version of OSI model. It was basically developed in 1960. Uh, it is stand for Transmission Control Protocol and Internet Protocol. Also, it is made up of four layers: application layer, transport layer, internet layer, and link layer. Data and signal. Okay, now in this section we are going to discuss about some common features of data and signals and their implementations. Basically, data is raw materials that is used by person, computer or application to process information, and signals are electromagnetic waves or pulse that move, otherwise travel across the transmit media from one end to another end. In data communication, data converted into the form of signals were required to transmit them through the network environment. Okay, signals can be classified to different types. We are commonly know that analog signals, digital signals. Furthermore, these analog and digital signals can be classified to many other subcategories. So, analog periodic signals, any analog or digital signal that represents its pattern over a period of time is called as periodic signal. This signal has its pattern continued repeatedly and is easy to assume or to be calculated. When discussing about signals, there are different characteristics. Peak amplitude. The peak amplitude of wave is maximum positive or negative deviation of a waveform from its zero reference level. Period. Period is a time that taken by wave to complete one wavelength or cycle. So this is very compulsory when discussing the further sections of the signals. Wavelength. Wavelength is a distance that wave can travel within one time of period. Frequency. Frequency is number of cycles that wave travels during 1 second of period. Otherwise, it can define as a number of periods that wave complete in a 1 second of period. Phase. Phase is commonly known as the place that the wave is exists relative to the zero time of period. Time domain. Signal can be defined as representation of change in values against some phenomena. Most common form of signals, such as sine wave, we represent them according to the change in amplitude. In time domain, the amplitude of the wave described as property of time in sine wave can be shown as it change in the amplitude against time. This process can be called time domain. In next slide, we have represent simple sine wave using time domain. Frequency domain. As same as in time domain, frequency domain represents the amplitude of the wave against the frequency. It means wave can represent as a property of frequency. In frequency domain, it shows that how amplitude is changing against when the frequency is changing. This graph displays how the frequency domain is work. Bandwidth of signal. When discussing about the signals, there are many different types of signals. When the signals are categorized as composite signal, it can be introduced as combination of different signals. In composite signals, there can be different waves with different frequencies and wavelength. Among these combinations of waves, there will be wave with minimum frequency and maximum frequency in composite wave, and the difference of minimum and maximum level range is taken as the bandwidth of particular composite signal. This graph shows the simple representation of signal bandwidth. Let's discuss about digital signals. Digital signals made up of ones and zeros. These two levels can be represented in two voltages. Digital signals convey fixed amount of bits within given time duration. This amount of bits within particular time called as bit rate or pulse rate. Digital signals also transmit in same pattern of analog signal. The central location of digital signal determined by the special bit code called clock signal. This clock signal help to filter out analog signal to digital signals. Digital signals with two levels. You can simply see this with this graph representation. Uh, Noise. Noise is another barrier in signal transmission. In general term, noise can be another signal that change the shape of signal during the transmission period. The noise can come from motors, current wires, from crossing cables, and from many sources. In this case, noise will damage the data of transmitting signal. Distortion. When the composite signal travel from different medias, it changes its shape different to its sending source. This is because each wave that made up the composite signal has different propagation speed. When the signal wave entered the new media, it changed the pace from different to each other. This is caused to change the shape of whole wave compared to the sending source. Pulse code modulation. Pulse code modulation or PCM is method that convert analog signal to digital signal. PCM is consist of three major steps. In next screens, we are going to describe about these three steps. Sampling. Analog signal is continuous signal that transfer over the time. If draw a graph, it can be shown as below. Sampling is process of finding sufficient number of samples so that the original signal can be completely presented by particular samples. Quantizing. If sampling is like drawing vertical lines, quantizing is like drawing horizontal lines. Then each sample matched with one specific horizontal lines. Sampling converts time varying signal into discrete time signals as a sequence of real numbers. This is the final step of pulse code modulation. It is encoding. Now each bit values can be matched with decimal numbers. Each sample can convert to binary from left to right or specific time, which means from 1 second of time of analog signal series of binary values can be extracted. This is how pulse code modulation works. Modulation. Modulation is a simple process that modifies some signal to the signal of different characteristics. Generally, there are three important characteristics of signal: phase, frequency, amplitude. The given formula represents the relationship between those characteristics. In modulation process, the above given characteristic is changed using a special signal called carrier signal. In this image, in this diagram, you can see this process simply. Uh, Modulation signal is comes from sender and transmitted to some destination with data or some values. Here carrier signal is high frequency or high energy signal. Finally, the modulated signal is the new signal produced after the modulating signal mixed with carrier signal called modulated signal. Why is this modulation is required? It is because for signal transmitting, reduce antenna sizes, avoid mixing of signals. Analog modulation, amplitude modulation. Here in AM, low-pass analog signal is converted to band-pass analog signal using the special high-frequency signal called carrier signal. This modification for the carrier signal is done using one of three characteristics of signal called amplitude. In amplitude modulation, the amplitude of carrier signal is changes corresponding to the modulating signal by change in the amplitude while keeping the frequency and pace constantly. This is another modulation method called frequency modulation. Frequency modulation is another analog modulation method for analog signals. As same as the amplitude modulation, here the carrier signal is modified using the modulating signal by changing the frequency of carrier signal based on the modulating signal. Here the amplitude and pace are the constant properties while the frequency is changing accordingly. Digital modulation. In digital modulation, the high frequency analog signal called carrier signal is changed relevant to the digital data or digital signal. Here, the carrier signal can be modified using its amplitude, frequency, and pace. Depending on the property that change in carrier signal, there are different types of digital to analog conversions. Amplitude shift keying. In amplitude shift keying, the amplitude of the carrier signal is changed relevant to the corresponding digital signal pattern. As a result, when the digital signal value is 1, amplitude of carrier signal remains its original value of high. When the value of digital signal becomes 0, the amplitude of the carrier signal becomes low or weak. ASK method does not affect the pace or frequency of the carrier signal and keeps them constantly. It is possible to change the amplitude of transfer signal to different level in different discrete values. However, in most cases, this is happen for only two levels as binary 1 and 0. Because of this reason, ASK also refer to binary amplitude shift keys or BSK or on-off key. Frequency shift key. In frequency shift keying is another digital to analog modulation type. Here the amplitude and the pace of the carrier are kept in fixed values while the frequency of the digital signal is changed time to time by mapping with digital signal. In general sense, when the binary value of digital signal is 1, the frequency of carrier signal changes to higher frequency. Digital signal changes value to 0, the carrier signal is changed to low frequency. Phase shift key. Phase shift key is digital modulation method which is use the phase property of carrier wave. As name implies, PSK changed the phase of carrier signal according to the particular bit values in digital signal. When the modulating signal changed the phase of analog carrier signal, it remained the amplitude and the frequency same as the original in carrier signal. Accordingly, the pace of the carrier signal changed when the binary digit 1 changed to 0 and vice versa. There are different forms of Pace shifting key, normally known as binary pace shifting key, quadrant pace shift key, octal pace shift key, and many more other forms. Through this video, we have discussed about different background elements and different essential things about wireless communication. See you with next chapters. Thank you.